Okay, we'll do these two together because they're same type of problem, just with two different answer types. So we're first going to write a function. What we're doing is we're saying the total cost C is based on the number of DVDs N that are bought, and how much does a DVD cost? 11. So every time you have a unit cost of 1 is this much money, we multiply the total number of units that you buy by the cost of 1 unit. And since they're $11 each, we say 11 times N, which up here it says is N is the number of DVDs. So that's the variable. So we know it's going to either going to be A or D. They both have C equals 11N. Now, what's the difference? One says continuous, one says discrete. What's the difference there? Well, this is a big idea in algebra and any kind of upcoming math that you're going to see. Here's the idea. If you have a number line, and let me just draw a number line here. Okay. If you have a number line and you have, let's say, between the numbers 1 and 2, here's 1, here's 2. In between 1 and 2, there is an infinite number of numbers in between there. From here to here, there's all the decimal numbers that start 1 point something. If you can think of any decimal number, 1 point something something, 1 point something 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 something, it's going to be between 1 and 2. And we can just forever, because we're not locked into any number of decimal points, we could say, where is 1.3765812? Where is that? It's about right there. So if we were moving along the number line and saying, I'm going to take a new spot on the number line, I'm going to plug it into the function, and I'm going to calculate it, get my number out. Well, if we plot that point, what we're suggesting is that's a legitimate number to plug in. So is 1.3765812, for example, a legitimate number of DVDs that we could buy? No, it's not. Doesn't make any sense. We can buy 1 DVD or 2 DVDs or 3 or 4 or 5 in whole number jumps. So, excuse me, if we are jumping values, we can calculate cost of 1 DVD, we can calculate the cost of 2 DVDs, but we can't calculate the cost of some decimal number of DVDs in between, then that is not a continuous situation. Continuous means that as we move along the number line, every number that we run into is a legit number for us to be able to, in this case, buy for the number of CDs or something like that. It doesn't make any sense. You can only buy whole numbers of DVDs. So this is not a this is not a continuous situation. This is a discrete situation where we're jumping in values. And some numbers, we call them domain values. Some numbers we're able to use as our domain values, numbers that we were allowed to plug in to check and to calculate, and some don't make sense. Now, so since the number of DVDs that we can buy jumps from 1 to 2 to 3 to 4 and not decimal amounts in between, we're going to say that this is actually a discrete situation, and the answer is D. So that's the idea. Now, it's important to note that it doesn't have to be whole numbers. I use the classic example of number of sandwiches that you can buy in Subway. You can buy 0 sandwiches. You could buy half a sandwich. You could buy 1 sandwich, 1.5, 2, 2.5 sandwiches. But you can't buy 2 and a third or 5.00681 sandwiches. Doesn't make sense. Doesn't make sense to calculate the cost of 6.00358 sandwiches because you can't buy that many. So that's not part of our domain. It's not part of the numbers that we're able to plug in to calculate how much the cost would be, because you couldn't buy that many sandwiches. So that becomes a discrete situation. It doesn't have to be whole numbers. You can buy half sandwiches as well. You can have half shoe sizes. I can be 7 or 7.5 in US sizes, or 8 or 8.5. And it doesn't always have to be that either. It could be like slices of pizza. How many pizzas did you eat? And then you and your friends are going to calculate how much you pay out of the total cost of it. Well, you could either eat 1/8 of a pizza if they're cut into eight, or 2/8 of a pizza, 1/4, or 3/8. You could have eaten much more than a pizza. You could have eaten 1 3/8, meaning an entire pizza yourself, and then 3 slices of another 8 slice pizza. And we can calculate, well, how much should you pay for that? But we're assuming that you will take full slices when you do it, and so that's going to be a discrete jump in jumps of 1/8, and you won't be calculating values in between that. So, short answer, when we say discrete, what we mean is we're jumping over values. Now, we could talk about this more, but what situations are continuous and what situations are discrete? Things that you count are discrete, right? You count the number of sandwiches you buy. Things you measure would be continuous. You measure the temperature, you measure the amount of water in something, you measure someone's height. You don't count their height, you measure it. And that is a continuous thing because if you are small and then you grow big, you hit all of the heights in between. And um, yeah, so that's the general idea between discrete and continuous. You probably want to work that out more if you don't really understand. But in our situation, it has to do with a word problem situation and what numbers are legitimate to use in the domain that we can plug in. And in this particular case, it only makes sense to plug in whole numbers because you can only calculate, or you can only buy whole CDs. Now, DVDs, sorry. Now, number 5, a produce stand sells roasted peanuts for $1.90 a pound. Let's assume that you can just take a scoop and you could grab any amount of peanuts and you weigh them. Okay? So if we're dealing with a situation like that where we're weighing loose peanuts, then conceivably we could have any amount of peanuts between 0 pounds if we didn't buy any peanuts at all, and however many pounds that we can buy, right? So let's just say between 0 and 1. Could we have half a pound? Sure. Could we have a third of a pound? Yeah, sure. We just take a smaller scoop. Could we have, we can use decimals as well. Could we have 0.1 pounds? Sure, we can take a small scoop, put it on the scale, and that's what it says that it weighs. And then we would calculate that number in our function as saying, I bought 1/10 of a pound of peanuts. And even though peanuts are individual things, they all come in different sizes, and through any combination of different sized peanuts, depends on your scoop, you could really kind of end up with any weight of number of pounds of peanuts. Versus if you could only buy the peanuts in 1 pound bags, then you would be counting the number of bags. That would be a discrete situation. You could either buy 1 pound of one bag, 1 pound of peanuts, or 2 pounds, or 3 pounds. But since they're wrapped up in bags, you can't buy amounts in between. Okay, that would be discrete. But if we're saying a situation where you're just weighing them and scooping them out of a bin and weighing them, then you could really end up with any weight, and therefore that would be a continuous situation. We should be able to calculate how much would you pay for this many or this weight of peanuts. So when you buy something that costs a per pound amount, you're going to take that variable, P, pounds, and you're going to multiply it by what does it cost per pound. That's the unit cost, 1.90 times the number of pounds, and that will be your total cost, C. So where do we see that? We see 1.90 times P. That's what gives us C, and it's a continuous situation because we can get any amount of peanuts that we want in terms of pounds. We can buy parts of a pound as well. So we're going to say the answer is A, and we're done. If you have more questions about continuous versus discrete, that's definitely something you want to come and work with me on a little bit during next week's enrichments or any chance you get. Anyway, good luck. This is a tough concept for people to get, but they get it when we talk it out. So ask me.